Have you ever just stopped and wondered, why are you here? I don't mean in a philosophical way, but in a real, physical sense. Why do you exist? Well, today we're going to dive into one of the deepest mysteries in all of science, this tiny cosmic imbalance that made the crucial difference between a universe full of stuff and one with absolutely nothing at all. Now, this question, why is there something rather than nothing? It sounds like it belongs in a late-night philosophy class, right? But I promise you, this is one of the most profound, most urgent problems in modern physics. Because, and this is the wild part, according to our best theories, the fact that you're even here to think about this question, well, it's a giant paradox. So, our story starts at the very beginning of time, the Big Bang. It was supposed to create perfect balance. For every single particle of matter, it created an equal and opposite particle of antimatter. But here's the catch. When matter meets its antimatter twin, they don't just shake hands. They completely annihilate each other. Poof, gone, in a flash of pure energy. This really leaves us with two possible outcomes. Over here on the left, that's the universe that should exist by all rights. A vast, empty cosmos filled with nothing but that leftover light. A sea of photons with no one around to see it. But then, there's our universe, on the right. The one with atoms, stars, galaxies, and you. The only difference? A tiny, almost imperceptible imbalance that let everything we know and love survive. So what was this imbalance? How on earth did matter win this cosmic war? The answer is basically a survival story with unbelievable odds. We're on the hunt for a cosmic clue, some tiny little flaw in that initial perfection that literally saved reality from disappearing. To really get a grip on the scale here, just try to picture this. In that chaotic, primordial soup of the early universe, 1 billion particles of matter were created alongside 1 billion particles of antimatter, all of them just rushing towards each other, destined for total annihilation. But it wasn't a perfect matchup. And this is what's so fascinating. For every billion antimatter particles, the universe somehow cooked up 1,000,000,001 matter particles. That single, solitary extra particle, that's the hero of our story. After all the fireworks, after all the chaos, after billions and billions of particles vanished, this is what was left over. Just one. One single survivor from that colossal clash. Every atom in your body, every star in the sky, is a direct descendant of one of these lonely survivors. So, here's our first clue in this cosmic mystery. A number, 10 to the minus 8. This represents a tiny proposed difference in the actual geometry of spacetime. Now, hang with me, we'll unpack what that means in a bit. But for now, think of this number as the theoretical smoking gun, the cause of the imbalance. And here's our second clue, which is the observable effect. This number, around 6 times 10 to the minus 10, is what we actually measure in the universe today. It's the physical proof that for every billion particles that wiped each other out, one survived. So we have our cause and our effect. Now, how do we connect them? It turns out the answer to this whole mystery isn't in the particles themselves. It's in the very fabric of reality that they live in. The key, it seems, is a fundamental flaw, a kind of beautiful imperfection in space-time itself. The fancy name for this idea is temporal chirality, but really, it's just a way of saying that time itself has a slight handedness, like being left-handed or right-handed. And because of this handedness, matter and antimatter don't experience the flow of time in precisely the same way. This is a great way to visualize what's going on. Imagine matter spiraling clockwise through time, and antimatter spiraling counterclockwise. In a perfect universe, their paths would be perfect mirror images of each other. But because of this tiny geometric twist, one path is just a little bit different. This creates a tiny phase difference. Basically, the tick of the clock isn't identical for both. And that minuscule difference gave matter the tiny edge it needed to survive. Now that is a fantastic theory. But is it true? How do we know? Well, let's look at the evidence, because we can actually see the fingerprints of this asymmetry all over the place, from the universe's earliest moments all the way to experiments happening right here on Earth. This timeline shows just how fast it all went down. At a mere trillionth of a second after the Big Bang, everything was still perfectly symmetric. But then, as the Great Annihilation kicked into high gear, that tiny geometric difference started to build up. By 1/1,000,000th of a second, the game was over. The asymmetry was locked in for good, and the tiny surplus of matter was all that was left. You know, what's so elegant about this theory is that it solves a puzzle that's been around for decades. Back in 1967, the physicist Andrei Sakharov laid out three conditions that absolutely had to be met for our matter-filled universe to exist. The incredible thing is that this one single idea, this geometric twist in time, it's like a master key that unlocks all three conditions at once. It just works. And we have hard data backing this up from the largest scales down to the smallest. When we look at the afterglow of the Big Bang, the cosmic microwave background, it confirms that 1 in a billion ratio. Here on Earth, in our particle accelerators, we've literally seen particles and their antiparticles behaving differently, just like the theory predicts. And when we look out into space, we see a universe of matter, with no evidence of the giant antimatter galaxies that should be there if everything were perfectly symmetric. So, what does this all mean for you? This isn't just some abstract cosmic bedtime story. This is your origin story. It connects the largest scales of the universe directly to you, sitting here right now. I mean, this really says it all. Every single atom in your body, every proton and neutron, is here because it was that 1 in a billion survivor from the Great Annihilation. You are, in the most literal sense, the product of a cosmic rounding error. Let's just connect the dots one last time. That initial geometric asymmetry led to that 1 in a billion survival ratio. That event left behind a cosmic echo of a billion photons for every single matter particle that made it. And from that tiny, tiny surplus came the roughly 10 to the 28 atoms that make you, you. So here's the crucial point. You are not just an observer of the universe, you are the evidence. Your very existence is the definitive proof that the fundamental laws of nature have a tiny, beautiful, life-giving flaw. We started with that huge question, and here we are with the answer. There is something rather than nothing because the geometry of space-time itself isn't perfect. Your existence and the existence of this entire magnificent universe is built upon a beautiful fundamental flaw. A geometric twist that turned what should have been an empty void into a cosmos filled with stars, planets, and people able to wonder about it all.